Preparing for a SQL Developer interview? You've reached Interview Guide, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between inner join, left join, right join, and full outer join?
Joins combine rows from tables using related columns.
In an inner join, I only get matching rows from both sides. A left join keeps every row from the left table and fills missing right side values with null. Right join is the mirror, and full outer join keeps unmatched rows from both sides. In interviews, I always mention cardinality, duplicate multiplication, and checking the join predicate before blaming the data. While answering, focus on how each join handles matching and non-matching rows, nulls, duplicate multiplication, join predicates, and when inner, left, right, or full joins are appropriate. Question 2. How do where and having differ in SQL, and when would you use each? Where filters rows before grouping. Having filters groups after aggregation. For example, where order date greater than 2024-0101 limits input rows, while having count greater than 10 keeps only groups that meet an aggregate condition. I use where whenever possible because it reduces data earlier and helps indexes. Having is for aggregate predicates like sum, average, count, or expressions based on grouped results. That distinction also makes execution plans easier to reason about. Make sure to cover logical query processing order, row-level versus group-level filtering, aggregate functions, performance implications, and examples where is preferred over having for efficiency. Question 3. How do you decide which columns should be indexed in a database table? An index is a lookup structure, commonly a B-tree, that lets the database find rows without scanning the whole table. I create indexes on selective columns used in joins, filters, ordering, and foreign keys. The trade-off is write overhead and extra storage, because inserts and updates must maintain the index. I validate indexes with explain, not guesses, and avoid blindly indexing every column. Composite index order matters a lot. In your answer, talk about B-tree basics, selectivity, composite indexes, covering indexes, write overhead, storage cost, and why execution plans should validate index choices in production. Question 4. What is the difference between a clustered index and a non-clustered index? A clustered index defines the table's row order, so a table usually has only one. A non-clustered index is a separate structure that points back to the base rows. I typically choose a clustered key that is stable, narrow, increasing, and frequently used for range access. Non-clustered indexes are great for alternate search paths, but can require key lookups unless they cover the query. Bad clustering choices hurt fragmentation and write performance. Be sure to mention table ordering, lookup pointers, one clustered index limitation, covering queries, range scans, key lookups, and how bad clustering keys affect writes. Question 5. How would you explain normalization and denormalization in database design? Normalization organizes data to reduce redundancy and avoid update anomalies, usually by separating entities into related tables. Denormalization intentionally duplicates or pre-computes data to speed reads. In OLTP systems, I start normalized for correctness, referential integrity, and maintainability. If reporting queries become expensive, I denormalize carefully with summary tables, materialized views, or cached attributes. The key is owning consistency rules, because duplicated data can drift if updates are not controlled. While answering, compare data integrity, redundancy, update anomalies, read performance, OLTP versus reporting workloads, and safe denormalization techniques like summaries or materialized views with ownership. Question 6. What are window functions, and how are they different from group by? Window functions calculate values across a set of related rows without collapsing each row like group by does. I use row number for deduplication, rank or dense rank for leaderboards, and sum over for running totals. Partition by defines the group, order by defines sequence, and frame clauses control the exact range. They are cleaner and often faster than correlated subqueries for analytics. I still check sort costs in plans. Make sure to cover partition by, order by, frames, ranking functions, running totals, deduplication use cases, and how window functions differ from group by semantics. Question 7. How would you find and delete duplicate records from a table safely? For duplicates, I first define the business key, because duplicate by email is different from duplicate by full row. Then I use row number, over partition by key, order by created at desk, to mark records and delete where row number is greater than 1. I preview the rows in a select, wrap the delete in a transaction, and keep the most trusted record. Foreign keys and audit requirements matter before deleting anything. In your answer, discuss defining the duplicate key, using row number, previewing affected rows, transactions, choosing the survivor record, and checking foreign keys or audit requirements. Question 8. A query is running slowly in production. How would you troubleshoot and optimize it? When a query is slow, I inspect the execution plan instead of rewriting randomly. I look for full table scans, bad join order, missing or unused indexes, high estimated versus actual row differences, sorts, spills, and key lookups. Then I check statistics, predicates, data types, and parameter values. The fix might be an index, sargable predicate, better join, materialized aggregate, or simpler query shape. Always measure before and after. Be sure to mention reading the execution plan, estimates versus actuals, scans, seeks, joins, sorts, statistics, parameter sniffing, sargability, and measuring improvements after each change. Question 9. What are transactions and ACID properties, and why does isolation level matter? A transaction groups multiple statements into one all-or-nothing unit. ACID means atomicity, consistency, isolation, and durability. Isolation controls what concurrent transactions can see, from read uncommitted through serializable. Higher isolation prevents anomalies like dirty reads, non-repeatable reads, and phantoms, but increases locking or versioning overhead. In real systems, I pick the lowest isolation that preserves business correctness, and I keep transactions short to reduce contention. While answering, cover atomicity, consistency, isolation, durability, dirty reads, non-repeatable reads, phantom reads, lock or versioning trade-offs, and keeping transactions short under concurrency pressure safely. Question 10. What is a database deadlock, and how can you prevent or resolve it? A deadlock happens when sessions hold locks the other sessions need, creating a cycle that cannot progress. The database usually detects it and kills one victim. I prevent deadlocks by accessing tables in a consistent order, keeping transactions short, indexing foreign keys, and filter columns, and avoiding user interaction inside transactions. If one occurs, I capture the deadlock graph, identify competing statements, and adjust indexes or transaction order. Make sure to cover lock cycles, victim selection, consistent table access order, short transactions, proper indexing, deadlock graphs, retries, and distinguishing deadlocks from blocking issues. Question 11. How do primary keys, unique constraints, and foreign keys differ? A primary key identifies each row and cannot be null. A unique constraint enforces uniqueness too, but depending on the database, it may allow limited null values. A foreign key enforces a relationship by requiring child values to exist in the parent table. I prefer constraints over application-only checks because the database protects data from every client. Constraints also help optimizers reason about joins and cardinality. In your answer, explain row identity, uniqueness, null behavior, parent-child relationships, referential integrity, cascading actions, optimizer benefits, and why constraints beat application-only validation for correctness. Question 12. When would you use a subquery, a CTE, or a temporary table? A subquery is embedded inside another statement, while a CTE names a temporary result for readability and reuse within one query. A temp table persists for the session and can be indexed or reused across steps. I use CTEs to clarify logic, subqueries for compact predicates, and temp tables when intermediate data is large or reused. Performance depends on the optimizer, so I validate with execution plans. Be sure to compare readability, scope, reusability, optimizer behavior, indexing options, intermediate result size, and when temp tables are better than deeply nested queries operationally. Question 13. What does it mean for a SQL predicate to be sargable? A predicate is sargable when the optimizer can use an index seek instead of evaluating every row. For example, order date greater or equal to 2024-01-01 is better than year order date equals 2024. I avoid functions on indexed columns, leading wildcard-like patterns, implicit conversions, and mismatched data types. Rewriting predicates this way often improves performance more than adding hardware. Sargability is basic, but it wins interviews and production incidents. While answering, focus on index seek eligibility, functions on columns, implicit conversions, leading wildcards, date filtering, data type alignment, and rewriting predicates for performance in practice. Question 14. How would you implement efficient pagination for a large table? For small datasets, offset and limit are simple, but large offsets get expensive because the database still walks skipped rows. For high-traffic pages, I prefer key-set pagination using a stable indexed sort key, such as where ID greater than last seen ID, order by ID limit 50. It is faster and avoids duplicate or missing rows during inserts. The trade-off is less flexible random page jumping. Always define deterministic ordering. Make sure to cover offset cost, deterministic ordering, key-set pagination, index sort keys, consistency during inserts, user experience trade-offs, and API cursor design for scale. Question 15. What is SQL injection, and how do you prevent it in application code? SQL injection occurs when untrusted input becomes executable SQL instead of data. I prevent it with parameterized queries or prepared statements, never string concatenation. I also validate input, apply least privileged database users, avoid exposing detailed errors, and log suspicious patterns. ORMs help, but raw queries still need bound parameters. In interviews, I mention that escaping is secondary, binding values is the reliable defense. In your answer, discuss parameterized queries, prepared statements, least privilege, input validation, error handling, ORM limitations, logging, and why escaping is not the primary defense. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.